Let's talk tactile communication. We currently live in this digital age where we're constantly bombarded with information from each and every direction, making it almost impossible to comprehend all of it. Intuitively, then, it would make sense to adapt our brains, originally made for the caveman era, to now the digital age. And the only way to really do this is to optimize the acquisition of this information that we're always exposed to. Why not then use our skin as an additional medium to communicate information, similarly to how we use our visual system or auditory system? I mean, it is the biggest sensory system we have, making about 20 square feet of available surface area. And that's the premises of this master's project. We tested the skin's ability to process simple forms of communication. Now, while this may seem useful to a lot of us, it's especially useful for blind travelers. Considering that they're already one sensory system short, their auditory modality is constantly saturated with different environmental information. And this makes it extremely difficult to simultaneously attend to all of it, which could lead to potentially detrimental effects, considering they could miss the sound of a car driving by because they're so occupied listening to GPS commands. It makes more sense than to redistribute this information across different sensory modalities. Maybe it might be better to use the sense of touch to process some forms of communication instead, such as directional commands. And that's exactly what we did through these experiments. We simulated an outdoor environment to learn how effective a tactile system really is at processing some forms of communication relative to our visual system or auditory system. This setup consisted of a fully automated participant localization system integrated with lasers and cameras all into a Labby software program. Apart from blind travelers, the application of tactile displays are endless. They could be used in any conditions with low visibility, or they could also be used to complement our other sensory systems. Ultimately, this research could be used towards developing a full-out tactile suit that could interface us with our surrounding environments, providing us with tactile information about surrounding events that we would have otherwise missed. Maybe it could be used towards tactile suits capable of rendering elements of a virtual environment.
That's a wrap.